Hi. How are you? Ebu, acha tu nizime mimi mwenyewe. Hi, how are you?
We are fine.
Me too, I'm very fine. No, don't make noise. I hope today some might see me. Today I'm not in, I'm not from abroad. Today I'm in Kenya. Okay, let us just begin with immediate effect. I hope I'm very clear. Winnie, you can mute your speaker or your rather than your mic. You mic. I can see people joining. Those who are want to learn something today. Feel more comfortable. Popo, let me mute you from this side. Oh, Popo is now muted. This B is also somehow, is also not, somebody is speaking here. Okay. You are, okay, it is good. Let us proceed just from where we left the other day. Let me just share the screen. Is it here, truly? Okay. Oh, so it should be able. This is a known one. So it was structured bonding. Dean, uko na simu? Okay, let me just now share the screen so that you can be able to see my screen just like that. Hope today you are able to see me. Today I'm not from abroad, I'm just within Kenya. So the lesson is just from just within. I am just in my room where we want at least do something just for today, and we should cooperate. Where you don't understand, be ready to ask a question, and we move together. I hope I'm audible, is it?
Yes.
Yes, my network is very stable. I paid for my Wi-Fi. Yes, you can see this. That is thank you. It is better we laugh for a while. That is very, very, very good. So the structured bonding, we had discussed one type of the bond that was, who can remind us what we did last?
Ionic bond.
Yes, we did ionic bond. That is very good. And I did say that people do, some people are were misled. Maybe it depends on where you got the first knowledge from, where they say that the ionic bond is a bond that exists between a non-metal and a metal, which is a very, very, very wrong definition. you should not take that definition home. That definition should be thrown next to a latrine which is next to you. Then you forget about it. So like today we had we had defined the bond, the structure, and the structure itself. We had described the nature of chemical bonding, and now we were just in the state and explain plus the illustrations on the types of bonds. Um, very, very, very good. So let us just continue without maybe wasting a lot of time. I can see people joining, those who want to learn. That is very good. Hi. The meaning of the bond we had discussed, and we said that it is a mutual force of attraction that holds particles together with the same or different atoms combined during chemical reactions. And also we had talked about the nature of chemical bond. We are now in the types of bonds. We have three main types of bonds, that is ionic bond, covalent bond, and metallic bond. We went ahead to see. Sorry, who is that making noise in class? I'll give you a suspension. Hey, not allow for making noise. Yeah, let me mute them or remove them from class. When they are tired of talking, they can come back. So let me remove you from class. Where can I see you? Faith is making noise, so let me remove Faith from class. Hi. We are now free to go. So we said that ionic bond is a bond formed due to the complete transfer of electrons from one atom to another, resulting into two opposite charged ions, where we said that for those who are making noise, kindly be. Okay, thank you, class representative Elizabeth. It is a bond formed due to the complete transfer of electrons from one atom to another, resulting into two opposite charged ions, where we said that the positively charged ions are also known as positively charged ions.
Cation.
Sorry?
Cation.
The cations. So the cations are the positively charged ions, which are formed when the metal loses electrons to become stable, loses electron or electrons to become stable. Well, when it is negatively charged, to mean it is called anions. So that is formed when the non-metal gains electrons, so they form negatively charged. Formation of ionic bond we did, you can check this one. I think now this is how the sodium illustration on the formation of ionic bond of sodium and chlorine to form sodium chloride. So sodium has 1 electron in its outermost energy level, and chlorine has 7 electrons. It is easier for sodium to lose its electron and form positively charged ions, and for chlorine to gain an electron, forming an anion. If sodium can transfer its spare electron to chlorine, as shown below, you will see it, both atoms will be satisfy their full outer shell requirements and ionic bond will be formed. If large groups of sodium and chlorine atoms bound to this way, they result to a three-dimensional structure, of which we are going to explain later there. So this is a chlorine between sodium and chlorine. So the bond that exists there is now the ionic bond, because there is a transfer of electron. So sodium transfers its electron to chlorine. So chlorine gain that one electron to become stable. When you are drawing, the structures must be in either octet or duplet, to mean it must be, all the atoms must be in a stable state, that is in somebody is asking me, yet I'm in class. So you can see, so if you see this, if you check this one, are you able to see my cursor on the screen?
Yes.
Yes, if you check this electron from sodium, it will be transferred. That is electron transfer to the chlorine. So chlorine will gain that one electron to, you can see it is here, it has been gained in this side. So both of them are stable, but you don't leave your structures there. So you can see the last, the last, that is the last bond after bonding. So this is the diagram after bonding. So we have this, the charge here, this is the cation charge and the anion. We said that in ionic bond, they form the opposite charged ions. You can see this is positive and this is negative. So, you know, the like and like charges attract, they attract each other in that manner. You can check it is stable. So when you are told to draw the structure, the bond between sodium and chlorine, this is what you will draw. So this is sodium ion and this is chloride ion. They are in ionic state. Then if you check now more example of ionic bond. So like magnesium chloride is also ionic compound. So if you check, magnesium is ionic compound because this compound is formed by transfer of electron between magnesium atom and chlorine atom and chlorine atoms. Because you can check here very well, we have two chlorine atoms. We have two chlorine atoms. So each sodium will transfer one electron to this magnesium. I mean, magnesium will transfer its one electron to one chlorine atom and one electron to one chlorine atom. To mean we will have two chlorine atoms structured drawn. You should be able to know that. So because magnesium atom and chlorine atoms, magnesium atoms loses two electrons to form magnesium cations, that is positively charged ion, whereas each chlorine atom accepts one electron to chlorine to form chloride ion, that is anion, the negatively charged. So each chlorine atom will gain one electron from what? From magnesium, because magnesium will donate, will donate two, will lose two electrons to become stable. So because now we have here two chlorines, each chlorine atom will take one electron from magnesium for them to be, for each to be stable. I think I'm very clear there. So magnesium forms ionic bond to chloride by donating. If you don't see the two here, to me that is now chlorine atom, the chloride, the chlorine atom. When there is no two here, you should know that by donating its valence electrons to chlorine atoms. The electron configuration of magnesium is 2:8:2. To mean these two, for it to become stable, the two will be lost. It can achieve a complete octet by losing its two valence electrons to form magnesium ion, that you can see there, where the now ionic configuration. This is now the ionic configuration of magnesium, but this is electron configuration. This is a ionic configuration. So if you are told to write a ionic configuration of magnesium, this is what you write. But you have to write the ionic state of magnesium, where you will write M, capital M, small g, then on top you write 2 positive, then you write 2:8. That is the ionic configuration of magnesium. Again, when you are writing, the charge should not become, the charge should not come first before the number. So the charge should come after. If the charge come first, that you are now talking about the oxidation state, the oxidation number. So you should know that. Check that the electron configuration of chlorine also is 2:8:7. It can achieve an octet by gaining 1 valence electron to form a chloride ion. So you can see here it is forming a chloride ion. So this is now the ionic configuration of chlorine. It gains, if it gains 1, if it gains, the charge become an anion, to mean the charge become positively charged. So it will be 2:8:8. So the one has been, it has gained 1 electron to become stable. You should know that. The oppositely charges of the magnesium and chlorine ions attract each other and form ionic bonds. You can check. Here we have, here in magnesium, there are 2. Yes, Elizabeth.
Please, teacher, repeat what you've just said. I haven't understood yet.
Okay, I've just said chlorine. We know that chlorine is atomic number 17. So we have the electron arrangement of chlorine. The electron arrangement of chlorine. If a chlorine is atomic number 17 and you want to distribute the electron to each energy level of the chlorine, what you have to know, the first energy level of any atom should be occupied by a maximum of 2 electrons. Then the second, from the second to infinity, where we don't know where it will reach, it should be occupied by a maximum of 8 electrons. So the first energy level of an atom, the maximum electrons should be 2. From now, the second energy level to infinity, it should be occupied by a maximum of 8. So dispute, here we have 17. So we begin with 2. We remain with, from 17 minus 2, what will we have? 17,
15.
we will remain with
15.
15.
15.
Yes, so
15.
15 is more than 8. Are you seeing that? So you write,
Ma'am, nyamaza.
we will remain 8. Then after that, so 15 minus 8, we remain with 7. So you can now write that 7. But for chlorine to be stable, it will gain 1 electron to become stable. And when it is stable, there is now ionic configuration. Ionic configuration of chlorine, which is now is 2:8:8. So it is stable, and in this state, it is now unreactive. It cannot react. So here, when you are told to write the ionic configuration, of chlorine, you must write the charge and the chemical symbol of the chlorine. You have to write. Then you write the electron arrangement, or the ionic arrangement of this of the chlorine, which is 2:8:8. You should know that. So now the second point here, the oppositely charges of the magnesium and chlorine ions attract each other and form ionic bonds. Where we said ionic bonds is now the complete transfer of electron from one atom to the other, whether it is different or the same. Usually, whether it is from the same atom or different atom, you should know that. Mercy has entered the waiting room. And how many masses do we have? We can continue. So if you check the first, what I've written here, the magnesium ion, you can see 2 electrons here. These 2 are the one that this magnesium is ready to give. You know, we cannot force it, but it is ready to give 2 for it to become stable. Kana kwamba haukuwa na unga, but the maximum number of unga that you can give, yenye wewe pia hautakuwa hautalala njaa, maybe it is 2 kg. So that is what the magnesium is giving to chlorine. And the chlorine, wawili walikuwa wanataka kulala njaa. So one wataelewana, watachukua moja moja. So you can see, so one will go to this chlorine, another one will go to this chlorine. Each chlorine atom must be stable. Each chlorine atom must be stable. You can see, come this side, you can see the blue here in chlorine. This blue is from magnesium. So this chlorine has gained 1 electron from magnesium. You can even count 1, 2, 3, 4, 5, 6, 7, 8. It is stable. Come to the second chlorine. We have 1, 2, 3, 4, 5, 6, 7, 8. Also, this one is stable. So these are the chlorine ions. Then there is that bond now that is forming ionic bond. Are we together?
Yes.
Yes, together we are very, very magnetic. Mr. Mbaluka used to say so. 2 electrons lost by magnesium atom are gained by chlorine atoms to produce magnesium ion and 2 chlorine ions. So here we are producing 2 chlorine ions. Very magnetic. Let's continue. The next slide. You can see that now we after bonding. This is what you come with. Are you seeing? So in the previous syllabus, people could just write, they draw one chlorine atom, then they multiply by 2, they write 2 somewhere there, which is, I advise you to throw that idea away. This is now the idea that you should be using. So each magnesium is attracted to each chlorine atom. So you unaeka hii unaeka magnesium, unaeka in between, then you now write, you draw the structure of chlorine besides it. Sasa huyu ndio mwenye boma, huyu ni maybe mama mdogo, huyu pia ni mama mdogo, so baba yuko katikati. Usiwaeke tu on the one side, watagombana. So you have to at least give uweke baba katikati. So that is what we are because I know, metals loses electron to become stable. Ndio maana the men usually say that they are metals. It is okay because you are hard. Let's see this one. So you have seen how I've drawn. This is the best one. So learn on how to draw it like this one. And the charges must be there, the opposite charges. These 2 positive means magnesium ilipoteza 2 electrons. Then this negative to mean one electron went to this chlorine, then 1 electron went to this chlorine. And you can see there, sorry, in each case, you can see here we have this cross from magnesium, also this cross from magnesium. Then this cannot here. Magnesium lost 2 electrons to form magnesium ions, which is that each chlorine atom gain an electron to form chloride ion. So this is a chloride ion, this is also chloride ion. Very, very magnetic. I hope we are together up to there. Any question? Mtu ameweka huyu. You know that is my tribe, so I do understand it very well. I am called, I check this one. Also, we have here magnesium fluoride. The bond that will exist between magnesium fluoride is also the ionic bond. I don't know whether you can be able to see this clearly. You can see this one. They are now, oh, sorry, don't say who is who. So you can see this one also, you can just draw the way we drew the bond. You can draw how we drew this one, just the same. You will be able to score everything. You can see this one, or we can place them the way I've placed them here. So each fluorine will gain one electron to form a fluoride ion. So you can see it will gain one electron from magnesium to form the fluoride ion. Just the same like that, like that. There is nothing new. Aluminum fluoride. So here you will see that we have 3 fluorine atom, 3 fluorine atoms. So magnesium loses 3 electrons to become stable, and therefore each fluorine atom will gain 1 electron to become stable, and that electron will be from aluminum. You can check this one. So if you check this diagram, I don't know whether you can expand it on your side so that you can be able to see it well. So here, these are the fluorine atoms. These are the fluorine atoms. So, and this is the aluminum. So each chlorine atom will gain 1 electron from aluminum to form the fluoride ion. So after the result, you can see this side, you can see the blue electron. That blue electron is from the aluminum, for it is stable. Now check the next slide and you will be able to see it well. You can see now after bonding. So you can see where I've drawn the aluminum in the middle, and it is surrounded by 3 fluoride ions. So this is what we have done. So each fluorine atom gains 1 electron from aluminum to form the fluoride ion. You are able to see that. You are able to see that. Very, very magnetic. Aluminum atom lost 3 electrons to form aluminum ions. You can see that. When it loses, the charge becomes positive, that is cation. Then each fluorine atom gains electron to form fluoride ion, which is negative. If it gains, the charge becomes negative, and it is now called anion or an ion. The way it depends from where you are rooted, or how you pronounce the word, your nursery teacher. Note, you should note this: aluminum chloride does not form ionic bond. So when you are told to draw the bond that exists between aluminum fluoride, don't draw ionic bond. This is why I said that those who defines ionic bond as the bond that exists only between all nonmetals, between a metal and non-metal, that one might lead you to the dust pit. At the end of it, you should not go to the dust pit or the dust bin. You are very, very magnetic, so you should avoid such definitions. Check this one. So instead, it forms a dimer. A dimer means we have 10 minutes. We have 10 minutes, they have reminded me. A dimer means it is a bond that consists with covalent and
5.
sorry, Elizabeth. Eliza
Minutes.
or Mercy.
Sure.
Yes.
Guy.
What is it?
10 minutes.
10 minutes, we will agree whether we can come back for another 10 minutes, then we sleep. Chukua dawa umeze, meza dawa bwana. Let's continue.
It's okay. It's all about sacrifice.
Okay, example of ionic compounds. So this also forms, and this is now the assignment that you should be doing. So the sodium chloride form ionic compound, potassium fluoride forms ionic compound, magnesium oxide also forms ionic compound, aluminium 3, muthe, very good, muthe. I've seen your hand up.
Just sorry.
Oh, sodium chloride, this forms the ionic compound, to mean they form ionic bond. So the bond that exists between those is ionic bond. Very, very magnetic. Example of ionic bond, ionic compound, we have discussed those one. So assignment, by use of dots and crosses, draw the electrovalent. The electrovalent is just the same as ionic bond between the following compounds: lithium fluoride, sodium fluoride, potassium fluoride, potassium bromide, copper 2 oxide, and lead oxide. I know where people will have a now problem is E and F. Somebody will ask me, how will I know the energy levels of copper 2 oxide? If you see anything written 2 oxide 2 here, 2 in the middle, these 2 stand for the electrons lost. Are we together? So 2 is for the electron lost. So like copper 2 oxide lost to copper lost to what? 2 electrons to oxygen. We know that oxygen, for oxygen to become stable, it gains it gains 2 electrons to become stable. Sawa. So what is the atomic? This is atomic. Copper is atomic number. Who can try? I know it is not in the periodic table, but for the search of my students, they can really try. Who can try and give us the? Who can try and give us? Who can try and give us? Who can try? I've just seen some text here. Okay, well, that is good. Okay. Hi. Yes, Dean, try. What is the atomic number for copper? Don't hide. No, we have not gone to what we are to discuss today.
Change it 29.
29. Very magnetic. Very, very magnetic. That is very correct. So if it is 29, Ebu, tell us the electron configuration. Tell us the electron configuration. Now you can't be able to tell us the electron configuration of that copper. We have said it is 29. And we said earlier that for an atom, the first energy level should be occupied by a maximum of 2 electrons. Then from there, you will be able to, do you have a mechanical problem? I hope everything is okay. Everybody is able to get me whatever I'm saying. Are you able to
Yes.
get? Okay, thank you. So I said that the first energy level is occupied by a maximum of 2 electrons. So for them to be 29, who can give us the electron configuration of copper?
Me.
Yes, Elizabeth.
2.
Who is speaking?
Mercy.
Oh, Mercy, speak. Very good.
28882.
2882. Add them.
21.
If you add them, what will you have?
One mwisho, then 29.
29. Okay,
Yes.
I can see Faith, your hand is up. The left today is I was just passing and akaona link. The left ameingia. Yes, Faith. Yes, Fatomayo is coming in. Faith, unmute your speaker so that you can speak.
Oh, it's okay. I wanted to say the same answer.
Okay, that is very good. So are you able to draw? Are you able to draw the ionic bond between copper and oxygen? So that is assignment. Make sure you send your assignment by the end of tomorrow. Giant ionic structure. Giant ionic structure. I want to discuss this later. I want just to go to, or should we discuss it? What we do, only 2 minutes remaining. Let us come back. How many people are coming back for maybe 10 minutes so that we just clear this? You know, we were to talk about the covalent, which is only 2 lines. Then we are.
Me.
Should we come back for at least only 10 minutes? I'll be a
Yes.
timekeeper. Dean also will be a timekeeper. So make sure you remind us, Dean, when 10 minutes is over, you tell us. Sawa.
Yes.
Let me end it. Then don't go for good, please. This lesson is very magnetic. It's a very, very magnetic lesson.
Okay.
So where do people end meeting? Oh, here.